Okay, today is Vectors Day 6, and we're started with a tough one. We had two three-dimensional vectors demoed in the room by a couple teams of kids, and from this line we got strung through the room so we can see 3D. And one of the vectors I gave all the dimensions, and I said it was just 1i, 2j, and 3k. The other vector we're calling the develop DEV vector, just because he had that on his shirt. And I didn't tell them all three. I told them two of the three, and I told them that the ruler's magnitude was 3 feet long. Okay, so if the ruler's 3 feet long, we can solve and figure out what that third dimension is, because we know the magnitude is the square root of all three dimensions squared. So your first job is to figure out z, as in how far out were they? All right. Now, will it matter which way they were? Let me ask you this. Will it make a difference in the angle? You saw the angles. Roughly, they were like this. And think about it. Would there be a different angle if it's like this versus if it's like that? Does it seem like the angle's getting smaller if I go the one way versus the other? Yeah, it is. So it makes a difference. Remember that they were going back. You guys were going negative, weren't you? Weren't you guys going back this way? All right. All right. But there's a difference between the two angles. You're not going to get the same answer for the angle between the two vectors. So you're right. You could have gone either direction, but you chose to position yours in the negative direction. So when you're done, make sure you realize that you're going to get two possible answers for z, and you want the negative one because that's what he displayed in class. All right, I'm going to work this out a little bit further because I'm seeing a few dazed looks on a few faces. Square root of 1 squared is 1, plus 2 squared is 4, plus z squared, I don't know. So then that's 3 equals the square root of 5 plus z squared. And then how do I fix this? Solve. How do you solve this? Square both sides. It becomes 9 equals 5 plus z squared. Keep on going. Can you just like see the answer? What's the answer? 2, but then I just said a second ago that we wanted the negative one, so negative 2. You got how there's two answers to this? 2 works, and also does negative 2, because when you square root a variable, you have two answers for that. Absolute value of z is 2. So then you got 2 or negative 2. And we in class had the angle going away from you guys, and that means that we were using the negative one. So z is negative 2. Negative 2 to be exact. Okay. So now that you know this is negative 2, okay, now you can find the angle between them. Would you please compare the angle that you have found with the kid next to you? When you're done. We're going to do, there's less kids in here. I'll pair you up. Pause for a second while I do that. Okay, did you get 169 if I remember right? Raise your hand if you were that's what you had. Okay, good. All right, and that was again found by doing cosine of the angle is dot product of these two. I'm going to put them in column form. A little quieter, please. Kind of impolite. Thank you. And 1, 2, 3. And then if we actually do the dot product, multiply across, multiply across, multiply across. What was the dot product? You all did the dot product. So what is it? Negative 11. Thank you. And then you had the two magnitudes. One of them was given to us as a magnitude of 3. And the other one's magnitude, we're going to multiply by, that one wasn't as nice. It was the square root of 1 squared plus 2 squared plus 3 squared, which was square root of 14, if I remember right. All right, so then how do you fix this? You get rid of the cosine by doing what to both sides? Inverse cosine. So in the end, you're going to get inverse cosine of that, which is how you get the 169. All right. Now, yesterday we did something different than the whole angle between. Here's one where you could add a twist to taking a vector that's pointing in a certain direction and then saying, okay, but I don't want it to be here where it starts at the origin. I want it to have its base over here and still be pointing in the same direction. Okay, and you wrote equations for that. You remember that? All right, so here's one. If this vector right here is 3 feet long and it is heading not directly towards you, but directly towards you and up 1 foot. It is not left or right. It is just straight towards you and up a foot. Write an equation for it. If I moved it so its tail was at -2, -2, what would the equation for it be? Hint, you could start by writing the equation for it where it is right here, and then all you got to do is move the starting point to -2, -2. Again, it's pointing straight towards you except up a foot, and it's 3 feet long. I'll pause for a second while you try that too. All right, so one more time, I'm just explaining the question. If I have a ruler pointed straight out at the class, if I had just left it here, if it was pointing just straight at the class and it was 3 feet long, what would its vector be? How far left, right does it go? 0. How far up, down did it go? 0. And then the third way is out towards you, which is what? So it'd be 0, 0, 3 if it was like this. If it was like this. Okay. Now, it's not a huge adjustment, but you have to say, okay, if I tilt it upwards, so it's now pointing up a little bit, how much? 1 foot up. Then it's 0i, 1j, and how much k? All right. So if it's pointing I, j, k, would you agree that it was not going left or right at all? Okay. Do you agree that it was going up? That's the j part. Okay. How much up did I say it was going? 1. And up +1. And then the last dimension is how far out towards you is it, and don't say 3 feet. Because the magnitude is 3, so you should be able to figure out this third one. Remember that little magnitude formula we just did a second ago? If it's 3 feet long, that's the square root of that number, and the mystery number. You'll have to figure it out. 0 squared plus 1 squared plus k squared, and that's going to be 3 equals square root of 0 plus 1 plus k squared, which really is just 1 plus k squared. Then how do you fix that? Square both sides. 9 equals square root of 1 plus k, not square root anymore, I just squared both sides. 1 plus k squared, subtract 1 from both sides. 8 equals k squared. So how many had square root of 8 before I did? Okay, good. So that was the third dimension. Again, it's not pointing exactly 3 feet towards you anymore. It's the square root of 8, which is a little less. Why is it not pointing 3 feet towards you? Because if it's exactly to you, no, I won't touch it, don't worry. Then it's like this, and as soon as I move it up like this, now it's not as close to him. It's like not 3 feet away from him anymore. Now it's 0 feet away from him if I tilt it all the way up, right? It's getting closer and closer and closer. And now it's pretty much touching. Okay. So it's not, this dimension is not 3 feet. It turns out to be the square root of 8. And what's the square root of 8? Well, you could simplify that to root 4 and root 2, and that's 2 root 2. So, all that to be said, so that I could figure out that is 2 root 2. Okay. Now I've got my vector coordinates. And now I asked you to move its little tail and give an equation for that. We'll call our vector vector v, and then our new equation for it is x, y equals the starting point, just where it was in the first place. It had its tail at starting point at 0, 0, right? We're going to move it in a second, and then we do plus lambda, and then this is where this and this and this go. 0, 1, and 2 root 2. Okay. How many of you can understand what I just did up there? Okay, now, and again, for those at home, if you couldn't see it in 3D, you had probably no chance of being able to figure this out. Given this vector, I asked them then, what if we moved it so its tail was at -2, -2? Okay, so here it is. It's pointing at you again, except up slightly. Then I can move it to -2, -2, and now that's the one that I need the equation for. So really, didn't I just change the starting point? Yeah, so I just changed the starting point from 0, 0 to -2, -2. Well, that's it. Raise your hand if you had it right. Okay, now, even if you didn't have it right, take it from here, and everybody rewrite that into parametric form, and then solve for lambda so you get it into Cartesian form. Yes? Yes, we actually should have 3. You're right. My bad. And -2, -2, 0. Sorry about that. I forgot we were in 3 dimensions. So, good point. Very good point. Now, parametrics always only had x and y. When you move through 3-dimensional, it has x equation, has a y equation, has a z equation. This should be the easy part. I get that the other part is stretching you a lot, but this part you should know from yesterday. Would you please compare your answer to the person I paired you with? See if you're getting the same little equations for this. Okay, so here's your 3 little equations. X equals -2, and I'm just going across the top here. I just got to pick up that lambda. It's kind of sort of missing it there, but plus 0 lambda. What the heck is 0 lambda? It's 0, and therefore it's just -2. Okay, the next one is y equals -2 plus 1 lambda. At least I got 1 lambda. And the last one, z equals 0 plus 2 root 2 lambda. Raise your hand if you had those equations right. Okay, good. That's called what form? Parametric. And then the third form is just to solve each of these and get lambda out of there. This one's already solved. Sweet, no lambda. This one, if I set it equal to lambda, lambda is y plus 2. And this one is, let me think, 0 doesn't really matter. So I'm just going to say z over 2 root 2 is lambda. And how do I do lambda for the top one? What was lambda equal to? That's kind of the point, right? What's lambda equal to? X plus 2 over 0 is not possible, right? All right. So what that's telling me is that x, let's talk about x in the context of the real problem here. Okay? That was this. Do you remember how we didn't have any x direction? Okay. So in Cartesian form, which is where you just have x's and y's, we didn't have any x. You know what I'm saying? We had y and z direction, but we didn't have any x. So we don't need any for that. And therefore, we only have these two. Could we say x is 0? Yeah, x was 0. Could we say lambda is 0? That's like saying time is 0. And always will be. And that doesn't make sense. Yes? Okay, if there had been an x, and an x was like, if this had a lambda in it or whatever, so then we could have an x thing. We just set them all equal. So like y plus 2 equals z over 2 root 2 equals the x part, which might be x minus 2 or whatever. If there had been an x, you just write them all three in a big chain like that. But we don't have an x this time, so we just don't have one. Okay. Now, that's just three-dimensional of what we did yesterday. So what's new? What's new is you need to find day 6 in the homework, and I'm going to start a homework problem with you that's a challenging one, and you're going to want to follow along with me on this. On mine, it's like page 40, but I'm not sure where it'll be on yours, so pause for a second while I pull it up. Okay, so here's the first day of day 6, and in my folder, that one's on page 35, but I'm not doing that one because these, frankly, these are assigned, but they are very easy. They are exactly like yesterday, as long as you remember this one important fact, that you can write these equations in more than one way, and that r, remember when we did this yesterday, we used x over y more often when we wrote our equations. So if you want to replace r's with x over y's, they're going to look more comfortable for you. So this one's just got the equations kind of munched together. So I could rewrite this as x over y 0.5 minus, and then we need our t out front. Wait a minute, they're using a t instead of a lambda? Yep, you can use any letter you want for lambda. I used lambda exclusively yesterday, but this is using a t instead of a lambda. Totally okay to do that. Okay, so I need this, I need a starting point. What's my starting point for part D there? 0.5 and 0.4, good. And then I need my lambda, but in this case, what's the lambda? T. And then I need my directions on which way to go. And what would they be? Negative 0.1 and positive 0.2. There we go. There, that's in vector form. So sometimes they just look funny, but they're the same. They're giving you the same data, just kind of in a different way. All right. This one, they want you to take vector form and turn it into parametric, but they've made 2 tweaks on you. This r could be made into a what? X over y, and that mu is taking the place of what? Lambda. So they're trying to get you used to the fact that you don't always have to have lambda there, and you don't always have to have x over y. You could have r. All right. So those problems, I hope, will be pretty easy for you. And there's an answer key at the very end of this thing. But these are tough, and I want you to understand why they're tough. If you have 2 vectors that are heading like this, can you tell that if I'm starting here on this one, I'm starting where my fists are, that if you go into 3 dimensions, it's a lot harder to make them hit each other? Get what I'm saying? If you're only 2-dimensional, you can only stay where the x and the y axis are. You pretty much, if it doesn't have the same slope as each other, they're going to hit eventually. This is easy. But when you take it and put it in 3 dimensions, you get how I could have vectors going like this, and they either kind of look like they cross, but they don't actually cross because it's in 3 dimensions. If there were 2 spaceships, they would have never hit each other with these trajectories. Okay. So also, you get that when we involve time, we could even stay in 2 dimensions. And if this vector is going way faster than this vector, that even though they're heading towards each other, they might not ever be in the same spot at the same time. even though this one went on this path, it might have already gone past it before this one touches that same ground. It's kind of like this. It's kind of like two roads in the desert that cross each other. But if this guy's flying along on a motorcycle here, and this guy's flying along on a motorcycle there, do you get that they don't have to hit each other? Even though they're going to cross the same spot, they don't have to hit each other because one might go first and then the other guy goes past him, behind him. You know, if the one's going, if they're not timed just right, they won't hit each other. Okay. But if they're in the same spot at the same time, then they're going to hit each other. Okay, so moral of the story. These two equations, A and B, are both examples where they will be in the same spot. They will touch the same XY, but they'll do it at different times. This one will eventually get to the same exact spot as this one will. They'll go across the same XY spot, like 2,16 or whatever. They'll both get there, but they'll get there at different times. What's time in A? Look at it. What's the timepiece, timekeeper in A? Lambda. What's the timekeeper for R2, the second one? Mu. So if we find that R comes out to like 2 and mu comes out to like 3, then we can figure out, all right, they may cross the same spot, but they're crossing it at different times. All right, so I was originally going to solve B for you, but it comes out to decimals and stuff. So I told first hour I was going to do this differently, but I've decided I'm going to do it the same way as I did it in first hour. I'm going to solve A for you, and I'm going to leave B for you to solve later at home. Now, the key on this one wasn't, I was having trouble finding it. I'm going to tell you right now, because, you know, I can tell you the answers. The point is not can you get the answer, or no, the point is not to write down the answer. The question is, can you figure out how to make it come up to this? So I'm going to tell you right now, your job is to do B at home, and you're going to figure out that lambda, write this down, will come out to -8/3. And mu will come out to -22/3. If you want to do it as decimals, that's fine. Just figure out what that decimal is. And those are lambda and mu. What that means is they are going to cross at the same point. They are both going to go across that same territory, but they're going to do it at different times. Now, in the real world, in our commons where we're rolling bowling balls, putting them on this ramp, letting them roll down, what if our two lines are set so they're going to, the bowling balls would cross? As long as you aim them not parallel to each other, the bowling balls would cross, right? So then what's it about? It's about time. It's about timing. So then do you get how you can back them up? And if this one's going to cross the spot at time equals 5, and this one's going to cross the spot, which would be lambda, by the way, and this one's going to cross the spot at mu equals 4, then I need to make one of them either go faster or one of them go slower, or just hold the ball for 1 extra second before you launch it. You get how if you delay one, slow one down by a second, then you can make them be in the same time. They'll hit that same spot at the same time. All right. So I know this is complicated, but stay with me. First step is rewrite this, and I'm doing one of your homework problems for you. This is one of your homework problems. I'm just doing it with you. First step is to rewrite that into the form we're used to. x over y equals 2 over 1. There's no fraction bar in there. 2 over 1 plus, they multiplied the mu in, so I'm going to take the mu back out again and have 1, 3. And you're right, that's a lambda. On the other equation, I'll do this in red. X over y equals 1, 3 plus, this is mu, 1, 2. There. All I did is clean up the vector form of the equation, so it's what we're used to. Any questions on that? Okay. Next step is usually write them in parametrics. We do need parametric form. It's so much easier in parametric form. So I'm going to rewrite this and say x equals 2 plus 1 lambda. And y equals 1 plus 3 lambda. Meanwhile, back in the red problem, x is equal to 1 plus 1 mu, and y is equal to 3 plus 2 mu. Now, does somebody see why I wrote them in parametric form? Because the x's are the same as each other, and the y's are the same as each other. You might say, why are the x's the same as each other? Because there's only one place where x is. If you can get them to both go through the same point, the x is the same as each other, and the y will be the same as each other. All right, so since all of this is true, I can set them equal to each other. And the x's are gone, and I've got it down to just mu's. I know it might bother you that the x's are gone, but we'll figure them back out later. But for right now, we're trying to figure out what's mu equal to. And so I'm going to say, this equation right here is 2 plus mu, no, lambda, 2 plus lambda equals 1 plus lambda. Mu. There we go. 2 plus lambda equals 1 plus mu. Any questions on that so far? I know you might be thinking, but that's not solved. Okay, it's got two variables. And I'm about to write my second equation. Does it sound familiar to have two equations and two variables that you can figure out the answer? It's kind of like these. Remember these? And you can take the one equation and stick it in the other and solve. You have two variables and two equations. It's called a system of equations. You can substitute the one in the other and solve it. So we're going to do that for this mu lambda situation. All right. Now here's the other equation we have. The other equation is these guys. And so that equation is 1 plus 3 lambda is equal to 3 plus 2 mu. Now, we'll just do the same thing we were doing to get things into Cartesian yesterday, which is to solve for lambda in both of them. We could have solved for mu in both of them. We could solve for lambda in both of them. I'm choosing to solve for lambda in both of them. So I'm going to subtract 2 from both sides. And I have lambda equals 1 minus 2 is negative 1 plus mu. And over here, solving for lambda, I'm taking away 1. 3 lambda is equal to 2 plus 2 mu. And then I'm dividing by 3. Lambda is equal to 2 plus 2 mu over 3. Please catch me if I make a mistake. Now, I've got lambda is this, and I've got lambda is that. So now I can set those equal to each other. Negative 1 plus mu is equal to 2 plus 2 mu over 3. Do you remember my rules for solving equations? You get rid of fractions, clear fractions. So what do we multiply everything by? Multiply everything by 3. That cancels that. Negative 3 plus 3 mu equals 2 plus 2 mu. Now it's getting simpler and simpler here. It's down to only mu's. And I'm going to add 3 to both sides. 3 mu equals 5 plus 2 mu. And I'm going to subtract 2 mu from both sides. 3 minus the 2 is 1 mu, just mu, equals 5. That means that when their x's and y's are equal, as in when they're in the same spot, the time counter on that one equation that had a mu in it will be at 5. Happily, the other one's much easier to figure out because we've already solved all of this. I can just take this mu and put it in anywhere I want. I'm going to choose to put it right there. And lambda equals negative 1 plus 5, which means lambda is what? Lambda must equal 4. So again, what does this mean? These are the time counts when they will be at the same x, y. Now this is really important. How do you know if you did it right? Problems that you can check are much better than not when you're on a big test, right? You can know if you did this right by seeing if I stick in mu is 5, I should get the same point as when I stick in lambda is 4. Because if they don't end up crossing the same point, then I'm toast. The whole thing just didn't work. So at mu is 5, where would that go? Personally, I'd put it in right here into these equations because that'll tell me x and y really quick. Remember, mu was 5, so if I put in a 5 here and a 5 here, then I've got x must be 6 and y must be 13. This one now, please, 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 come out so you are at x equals 6 and y equals 13. That'll mean they both crossed the same spot, but at different times. One did it at time 5, the other one did it at time 4. So now let's see if we stick a lambda is 4 into this one. Anybody already do it? Did it work? So 2 plus 1 times 4 is 2 plus 4, which is 6. And y equals 4 times 3 is 12 plus 1 is 13. Y equals 13. Yay, it worked. I win. Okay, so your job, I already told you what B comes out to be for lambda and mu. You can try to replicate that answer. Make sure that when you rewrite these equations and put them into parametric form and solve them, that they come out to the same thing that I said they would. And if they're really the right answers, what I said is really the right answers, you should be able to tell me where did they hit? Where is the XY spot where they hit? All you got to do is stick in, if I told you what mu is, stick it in, figure out what the answer comes about to be. I told you what lambda is, stick it in, figure it out. All right, so that problem's the most important one because it's the R3 challenging level one, but there was definitely stuff above it that you should practice. So do with problem 8, part B, as well as the ones above it. And that's all I've got for you for today.